All right, here we go with 16.2. I hope this one makes sense. I sulfur when you are gone. Anyways, okay. 16.2, our objectives. You should be able to solve problems involving the molarity of a solution, describe the effect of dilution on the total moles of solute in a solution, and define percent by volume and by mass solutions. Okay, and then here's another joke for you, just an extra one. Okay, but really do drink water, please. 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 Okay, we'll move on. Molarity. Okay, I know that you keep getting introduced to all these things, but if you would like to be a TA for me next year, I would love, love, love it if you knew molarity and molality, because then you could help me mix chemicals for next year's chemistry students. Okay, I have to do this almost every lab where we are mixing chemicals because I need to figure out how much of the solute do I mix into the water, okay, to get the right molarity so that the reactions will happen. And so molarity is dealing with concentration. How much solute do I have in this given solvent? If it's dilute, it's weak. It has fewer particles of solute, and if it's concentrated, it's a strong concentration. It has a lot more solute particles in it. And so we have a formula as given below, and molarity is a capital M. So capital M equals moles over liters. And I have a diagram for you somewhere in this PowerPoint that you can kind of switch those things around and still get the right formula. However, this one is not too complicated. You've got molarity equals moles divided by liters. Okay, and so we're going to go ahead and do a problem to work with that. And if you're following, we're on page 481. You're given an IV saline solution, okay, when they have to put a needle into your body. Saline is like a salt solution. So one saline solution contains 0.9 grams of sodium chloride in exactly 100 milliliters of solution, which is usually water. What is the molarity of the solution? So as always, step one, what are your knowns, what are your unknowns? And so we've got those listed for us. Okay, there's a tip at the bottom. It tells us to convert the concentration from grams per 100 mole to moles per liter through the sequence below. So you've got grams per milliliters to moles per milliliters to moles per liter. Okay. And then you solve for your unknowns, which you have your formula for. So the solution concentration, or conc, is your 0.9 grams of sodium for 100 mils of the solution. You're going to multiply that by the molar mass of sodium chloride, and then you're going to multiply that by 1,000 milliliters to convert from milliliters to liters. Sorry, airplane. I tried to project. And your answer is 0.15 moles per liter, or 0.15 molars. Okay, and we would call it molars. So number 3 is, does this make sense? And the answer is it should, because you should have an answer less than 1 molar, and you do, okay, because you have 0.9 over 1,000, which is here behind my head a little bit. Sorry. Okay, so then we move on. Here's that diagram I was telling you guys about. Okay, you've got moles over liters will give us molarity. Okay, sometimes you are not given, or you are given molarity, but you're asked to solve for moles. So you would just rearrange this equation, which we've done for you here. You want to find moles, and you have molarity times the liters of your solution, which we just give the symbol V, because it's a volume. So moles of solute equal MV. Okay, and so an example, if you have 2 liters, it's a volume, of 2.5 molars lithium chloride, how many moles do you have? And so we want to find moles, and we've got our molar times our liters, and we get 0.5 moles. Okay, so in that solution we have 5 moles of lithium chloride. So I would like you to try a molarity problem and give me your answer in the box. Again, I don't know the side. Do number 11 on page 482. Alright, so with making dilutions, this is our next part, we are dealing not with a reduction of number of moles, but more so the solvent. Okay, the volume changes, but we keep the number of moles the same. Okay, so moles of solute before the dilution equals the same number of moles of solute after the dilution. Therefore, since you're not changing moles, you can use the following equation. Moles of solute, okay, you've got your initial molar and volumes, and your secondary, your final molar and volume amounts. Okay, and so we're going to do a problem to test that we can do this. So again, we're on page 484. Our problem, how many milliliters of aqueous 2 molar magnesium sulfate solution must be diluted with water to prepare 100 milliliters of aqueous 0.4 molars of magnesium sulfate. So we need to change the, in changing the molars, how much solution do we need to dilute? Okay, how much solvent do we need to add? And so step 1, write your knowns and your unknowns. Okay, hopefully this repetition is setting in good practices. So our knowns are written. We have M1, M2, V2, and we know our formula. So our unknown is V1. What is our initial volume? We're not given that. Okay, so step 2, plug in your information into our formula to find how much volume we started with. Okay, and so you end up with 20 milliliters. Okay, so you have 20 milliliters of 2 molar magnesium sulfate, and we diluted it to 100 milliliters to get the 0.4 molar solution. So you want to make sure, does it make sense? It explains why it makes sense on page 484. You can read that. If you have questions, contact me. Okay? All right. And then we have percent solutions. Okay, I think. 1 second. Yeah, percent solutions. So now the concentration of a solution in a percent can be expressed or written or solved in 2 different ways. One is by volume and the other is by mass. And so you have both of those formulas below for you. Okay, so you would take the volume of the solute, divide it by the volume of the solution, multiply it by 100%, and you get your percent by volume. Then for mass, you have your mass of the solute divided by mass of the solution, multiply all of that by 100%, and you get your percent by mass. Okay, so just to walk through percent by volume to give you one of those 2. What is the percent of, that should say volume, of ethanol in the final solution when 85 milliliters of ethanol is diluted to a, again, that should say volume, of 250 milliliters with water? Write your knowns, your unknowns, and then solve for the unknown. So we know volume of ethanol and the volume of our solution and our formula. What we don't know is the percent of ethanol by volume. So we plug those in. 85 divided by 250 multiplied by 100, and you get 34% ethanol. Okay, so the answer is reasonable. Again, you can find out why on page 485. But go ahead and do practice problem number 15 on page 485 for me. All right, just one last point for you guys. With 16.2, we're dealing with concentrations of solutions, and you might be asking, okay, what has this got to do with me? And I think that's one of the more important things that we should focus on. How does this stuff relate to us? And my mind always goes back to anatomy, okay? I can't wait for most of you guys to take anatomy. And physics, but anatomy I get to see you guys. We have our blood, okay, and our blood needs to stay at a certain concentration. If it gets too concentrated, maybe we have too many ions, okay, that can make our blood acidic, and it can increase our blood pressure and cause a lot of problems in the body, and it's not good at all. And so your body will regulate that by diluting your blood. And so it sends a hormone. You can ask anatomy students, they're learning this right now. But a hormone is sent to your kidneys that says, okay, or your kidneys send out a message and a hormone is made, and it tells your body that you're thirsty. And so you drink and you drink and you drink a lot of water. You just crave water. And then your blood gets more diluted, and then you can shut off that hormone and not have to drink as much. And so your body has all of these different mechanisms set in place. God has designed it so wonderfully and specifically to make sure that it runs as best as we can, okay? That our bodies will run as best as they can. Another way is for kidneys, okay? Your kidneys are filtering that blood, and so their job is to pull out ions, to pull out water, if your blood is too concentrated or too diluted. And so it will regulate and make sure that the correct amount goes back into the blood, and what is not needed in those amounts is removed. And it has all these different ways to double check and make sure, like just one last step before you have to pass that waste material out of your body through urine. But it has all these extra steps just to make sure that you get the right things put back into the blood and the right things removed from the blood. And so, again, if that doesn't work, then you develop kidney failure. And, I mean, you have two kidneys, but kidney failure is not something you want. And, yeah, so the body will shut down those kidneys if they're not doing their job properly, which would shut down your whole body eventually. So all of this stuff is in place to make sure that you are working properly. And I just thought that was a cool plug into how chemistry relates and works inside of our bodies. I hope you enjoyed that little anatomy fix. I will see you guys later.